All right, so what happens when we've got some restrictions on how we arrange our objects? So in this one, we've got to use the digit 0, 1, 2, 3, 4, and 5 without a repeat, and how many odd digit numbers are odd 3-digit numbers are possible. So I'm going to lay this out again in my boxes. I want a 3-digit number, so I want 3 boxes there, and it's got to be odd. Well, that means the last digit has to be 1, 3, and 5. It's also going to be a 3-digit number, so the first one can't be a 0. So I generally go with the most restrictive one first. I have to have a 1, 3, and 5 at the beginning. So that, at the end. So there's 3 options for that last digit. Now, one of those 3 is gone. Also, I can't have the 0 for the first digit. So I'd get left with 4 options for that first one. So that's also restricted. Now, the middle one is totally unrestricted. So I've used 1, 2 digits. I had 6 digits. So I must have 4 for that one. I multiply them all together and I get 48 possible 3-digit numbers that are odd using the digit 0, 1, 2, 3, 4, and 5. Now, what happens if I'm wanting to group them? So here I'm talking about things that have to be next to each other. So if 5 friends go to the movies together, how many ways can they sit if Sam and Joe must sit together? Here, what I'm going to do is go, well, we've got 3 friends other than that, and we're going to treat Sam and Joe as a single entity. So we can think of them as a 4th friend, as it were, but pair. So we've got 4 different factorial ways of arranging the 4 groups. The 3 single friends and Sam and Joe together. Now, Sam and Joe could be this way or that way around. So there's 2 ways of doing them. And in general, if I had 3 objects together, then there'd be 3 factorial ways. So it's actually 2 factorial. As it turns out, 2 factorial is just the same as 2, because it's 2 times 1. Here we've got 4 factorial times 2 factorial. Put it in our calculator, and we happen to get 48 come out again by happenstance. All right. So let's look now at a third problem. How many ways can rearrange the letters of mathematics if all of the vowels and all the consonants are together? So what I'm saying is all the vowels are together, all the consonants together. Well, let's go through and count the number of vowels. I've got 1, 2, 3, 4. So I've got 4 of them. And I've got 1, 2, 3, 4, 5, 6, 7 consonants. Well, if all the vowels are together and all the consonants go, I know they're vowels then consonants, or consonants then vowels. So they're going to be 2 factorial. And then I talked about a moment ago when I've got lots of objects together, in this case 4 vowels, there are 4 factorial ways of arranging them and 7 factorial ways of arranging the consonants. So the first 2 factorial is for vowels first or consonants first. And then the 4 factorial here is the ways that we can arrange the vowels, and the 7 factorial is the way we can arrange the consonants. Now you might say, but I've got 2 M's there, and they're identical, and we'll talk about how to deal with identical right now. Currently, we're considering the 2 M's to be different and the 2 T's to be different when we get to the 7 factorial. We will deal with in a future discussion about how to deal with that. Now we put that into our calculator. That one I'm going to have to pull the calculator out. And I get 241,920.